So today we will discuss, we continue discuss question about pKa, pH, and everything related with these questions. And as I promised, we will discuss some questions similar with GAMSAT. And at first, I want to start with announcement questions about phosphoric acid. It's one of major buffers. What at which concentration concentration of these particles, in which pH concentration of these particles same. It's ion of phosphoric acid ionized H3PO4. If we multiply even like into H2PO4 minus plus H plus and into HPO4 2 minus and H plus and final dissociation PO4 3 minus plus H plus H plus and plus H plus. Any constant of equilibrium mathematically equal with pH at the middle of neutralization. As I say before, according Henderson-Hasselbalch equation, if we're dealing with concentration of acid and concentration of salt ratio 1 by 1, we deal with pH equal pKa, because logarithm of 1 is 0. It means concentration of phosphoric acid with concentration of these ions will be same if pH equal 2.2, and concentration of these particles will be equal if we're dealing with pH 7.2, and concentration of completely dissociated phosphoric acid with HPO4 2 minus, this ions name hydrophosphate will be 12.4. Here question about this one, questions about of equilibrium to these ions, and these ions concentration will be same if pH equal 7.2, but we haven't 7.2, so here correct answer is there is no correct answer. So pKa equal pH if 50% of acid exists in ion form. And let's solve something more complicated. Find pH of ethanoic acid as a standard condition with pKa equal 4.76. Here I will solve more long way. At first I will find Ka. Ka is 10 power minus 4.76. It will be 0.1. It will be 1.73 times 10 power minus 4. Acetic acid, we will see it in organic chemistry too. It's CH3COO minus, and this acid ionized into CH3COO minus plus H plus As I say in lesson about acids, if you're dealing with COOH, it's mean acidic groups. And if we're dealing with weak electrolyte, we can build something like table before dissociation and after dissociation. Before dissociation, we have 0.1 acid, and we know CH3COO minus and no H plus ions, so we can, for example, use it as X. And according dissociation equation, ratio of anions and cations 1 by 1, so we can write 0, but then we get XX, and we left 0.1 minus X, and it's almost like 0.1. So we can oversimplify, and for continue of solving this problem, we can create constant of equilibria. Constant of equilibria, it's products, and divided by reagent. So constant of equilibrium, it's X times X divided by 0.1. 0.1 minus X will be almost 0.1, so we can simplify, and we get, and constant of equilibrium, as we mentioned before, it's 1.73 times 10 power minus 5. So 1.73 times 10 power minus 5 equal x squared divided by 0.1. And we need to solve this equation. X squared equal, if we multiply this by this, we will get 1.73 times 10 power minus 6. And X will be square roots of all of this. And it will be equal 0.1 to 10 power minus 3. And we're very close to pH. We find concentration of H plus. According definition of pH, pH is minus log 10 of H plus, and it will be 2.9. It's our pH. So what we must memorize for dealing such questions? At first, we must memorize definition of constant, definition of pKa, and equation, Henderson-Hasselbalch equation. And second, what we must to do, sometimes if you have more short questions like this, you need to just write all possible form, especially if you have with weak electrolyte, weak acid, weak base, with multiple step dissociation. It's like phosphoric acid, it's like citric acid. You must write each form and write equilibrium point. So at the 2.2 pH, we dealing with equilibrium with this and these particles. With 7.2, it's very close to our blood pH. We dealing with equilibria, these ions and these ions. And we never have in our body very alkali pH, so PO4 3 minus we never see in our body. So for today, I think it's all what I planning to tell. Next lesson we will discuss more tricky questions. It will be questions about of Le Chatelier principle and about how constant can be changed. Sounds strange. Constant is something what constant, but sometimes constant changing, and we can solve this problem by using Le Chatelier principle. Thanks for all who watching. Subscribe, share. Bye.